And welcome back. Now, no, I haven't taken up smoking. Don't get put off by the pipe symbol there. I thought I'd show you this Nunchuck, this Wii Nunchuck, not an original, I hasten to say, and how I've connected it up here so it can be used in Arduino type projects. Yes, I mean, until a few weeks ago, I hadn't even realised that they had these sort of things. Yes, all right, I understood about Wii gaming consoles and things, but I've never actually played about with a Nunchuck like this. And for those of you who are similarly living in a cave, it's just a nicely shaped thing that you can hold in your hand. It's got a little joystick thing at the top here, you can, left, right, up, down, whatever, and two buttons on the front, C and Z, which presumably stand for something, but I don't know what. And yeah, as part of this project that I'm building, I need this for the remote control aspect. So that's what all this is here. But I thought as I was doing it and finally wired all this up, I thought, yeah, I'll share this with my viewers, because if I'd known that this was so easy to use, I probably would have used it in other projects. Now, I want to give a quick shout out to JLC PCB. Now, they've supplied many PCBs to me over the last 2-3 years. And yeah, it's all very well for me to stand here and go and use JLC PCB, but let me give you an actual practical example of the sort of thing they can produce, shall we? And then I want to have a very quick word about shipping. Right, I've just had the PCB delivered for the other half of this project. It's this one here. I haven't even unpacked it properly yet, as you can tell. So as you can see, it's not a complex board, but it is a bitty board, isn't it? Lots of pieces on it. And yeah, I mean, it's done wonderfully well. Now, I made this using Easy EDA, which, as you know, is part of that group, JLC PCB, lcsc.com for the components, and Easy EDA. Now, within Easy EDA, you can do a lot of things that you would never expect to do otherwise. For example, if you've noticed here, I've actually removed both the copper and the solder mask from that hole, because that's going to have a push button in there. And I thought, no, I don't really want this sort of ground plane, which is what this is at the back here, going over this hole, and wasn't quite sure if it was going to be connected. So I just drew it out and said, don't put any copper here and don't put any solder mask there either. So it's just back down to the bare PCB here, which is exactly the way I wanted it. Yeah, push it on, it says. Oh, and it will be. So the shipping options to the United Kingdom, at least, as you can see, there's quite a few here. Now, the DHL, which is what I use, or have always used more or less, is obviously the quickest. You'll get it within 3-4 days. And in fact, DHL even tell you, oh, this will take a week, will be by the end of the day in a week's time. And then they send you another, oh no, it's coming today, actually. So yeah. Now, this bit here, DDP, that's duty and customs paid at the point of sending it out. So you pay a bit more up front, but then you don't get charged any duty, import duty, VAT, or anything else. Okay, so that's something to bear in mind, and you've got to weigh up the risk there of that happening. But if you look right down the bottom of this list, look, there's a GB Special Airmail, Royal Mail. It's only $5.35. Now, I tried that out, I don't know, 2-3 months ago, and it was just absolutely fine. It says 10 to 15 business days, and it was about 2 weeks, actually, when I got it. So if you're looking for a cheaper option, try that out. And don't forget the special assembly offer they have. If we look here for the SMT assembly option, you'll see you can get a coupon that takes the $7 off for the setup fee and everything else. Why don't you try them out now? If I'd known that this was so easy to use, I probably would have used it in other projects. Let me explain. Normally, if you want some kind of joystick control, you might use one of these. So this is a tiny little joystick. Now, yes, be careful. This one has actually got switches on the side and variable resistors. Let's get that in focus. So it is actually analog in that sense, right? So you can swing it backwards and forwards, and you'll get an analog reading depending on how far you push it, rather than just switch left, switch right. No, it's X degrees left, X degrees right, and so on. And the switches on the front, well, on the top there's only one actually. That's when you push it down. So as you can see, you can probably hear there's a clicking action there. And that's what pushes that down. So that might be what you would normally use in a project if you just wanted a joystick thing. The problem is, how do you mount this? Yes, I know it's got mounting holes on the actual thing, but you'd have to then cut a hole out in your project box and things. It's probably not too difficult, but not something I'd leap into doing. So when I discovered that, in fact, this project called for a Wii Nunchuck, and even better, yes, we do have analog control on this device here, but it's controlled by I2C, which, as you know, is just so simple to use. So let me get all this connected up, and I'll show you a little running demo about how it detects left, right, up and down. And even better than that, there's something else built into that Wii, and you can buy these very cheaply. So if you think, yeah, I'll have that for my project, because it's not a king's ransom at all. Let's have a look. Right, I've just got the Arduino, I was going to say Arduino IDE debugger. It's not. This is Cool Term again, just a standalone COM port monitor. It just makes it easier when I'm doing filming and stuff. As you can see, there's stuff on that window now that says, you know, left, right, and all that. So I'll show you the sketch, and I'm using a library because apparently everybody's doing this. I mean, I've been living in a cave. So I've changed the code for this demo code, so that it'll only display something up there when things change. So if I go left a little bit, in fact, if I go left, -43, -127, that's as far as you can go. And if I release it a tiny bit, look, so you can see it changing until it goes to the center point. Ditto, well, if I do it really quick, up, there we are. And if I slowly release down, you'll get the analog changing, you see. So it's analog, all via I2C, and ditto for left and right and all the rest of it, okay? And also the buttons. If I press the bottom button, it says the Z button was pressed and then released, and ditto for the C button. And I want to use that Z and C, even if my project doesn't make use of that, which it doesn't seem to. In fact, I think I mentioned this before. So you can then connect this directly into your Arduino. Let me show you what I mean. I'll take this serial monitor off. Right, so what have we got here? There's a few wires that make it a little bit difficult to show you, but basically this is a standard USB to serial converter because I'm using a Pro Mini down there. And the reason I'm using a Pro Mini in this particular project is because it's small. Good size, smaller than the Arduino Uno, for example. Maybe I could have got away with a Nano in here, but I thought, well, I've got these minis, so let's use them. A Mini, incidentally, is exactly the same as an Arduino without the USB bit. So if you think back to last week's video when I showed you the Arduino with the broken front end, the USB, imagine that USB bit cut off and not part of that Arduino board. That's what a Mini is, right? So the only way you can communicate with that Mini now is either via the USB to serial converter, FTDI or CP2102 or something, or if you're not interested in the serial communication backwards and forwards, you could program that using ICSP pins, you know, pins 11, 12, 13 and reset plus power. But mostly I think we do want serial. So this is the way to do it, and the pins are all on here. Now, not every Pro Mini is the same. For example, there's one at the back here that I did consider using briefly. Now this one has got, if I should bring it nice and close, you'll see that on the right hand side, yeah, there with that arrow showing, those pins are in fact A4, A5, A6 and A7. Unfortunately, they're not spaced properly, so you can't plug this now into a breadboard, which makes it extremely annoying. And as I've already desoldered these pins once, and in the process destroyed A6 and A7, which I wasn't going to use anyway, because you can only use A6 and A7 as inputs, analog inputs on the 328P. It's no big loss, but I don't want to start desoldering stuff again. But that is obviously a different layout to this one here. If I put them side by side, get this multicolored cable out of the way, you'll see that, okay, although they've got their pins on the right hand side, A6 and A7 on the top one is there, where you can see, yeah, that's the yellow and orange little pins there. That's the, did I say A6, 7? That's A4 and A5 at the top there. 6 and 7 is over on the left, yeah, there. So that makes that one a little bit difficult. And those holes there don't correspond to breadboard layouts either. So they are extra tagged on. So in a way, neither of these boards is perfect for breadboard use if you're going to use those extra pins. Additionally, the pins on the right hand side, which are all for the serial use, so you've got VCC and ground, you've got TX, RX, which swap over to the corresponding pins over here, TX on here, goes to RX on here, and vice versa. You may notice that there's no markings on the top here, because if we flip it over, the markings are on the other side, and it says Pro Mini top, but it's the wrong way around, isn't it? Yes. Well, the manufacturers of the Pro Mini here decided to put those pins on the top in the reverse order to the one on the bottom. So you really have got to have your wits about you when you buy these things from the Far East. Yeah, they work, no problem at all, but they are not equal. Just because you've got a Pro Mini already with a certain pin layout, it doesn't mean your next one's going to be the same. Unless, of course, you've done the research and had a look at the photos of the product they're actually selling. And you could get caught out. I mean, if you've made a PCB or stripboard layout for a particular Pro Mini, this one for example, and then you go and order a load more like I did, and you suddenly discover all the pins are in the wrong place, that would be disastrous, wouldn't it, really? As it happened, I'd already got these in my little store cupboard, and when I got them out just to sort of compare, I thought, hang on a minute, this isn't right, there's something going on here. So I was aware of it. So the Nunchuck, which is on I2C, and as you will know, okay, question for you at the back there. Which pins do we use for I2C if it's not specifically marked as such on the board? Yes, you at the back. What's that? A4, A5? Correct. Yes, SDA, SCL. That's right. That's what I2C pins are used for on the 328P. Obviously, if you're using them for I2C, you cannot use them for analog work. A4 and A5 are then used for the I2C only. And it's very simple. You just use the wire library. You'll see the sketch in a second, and it all just works by magic, especially if you use libraries. If you use the libraries, so somebody's done all the hard work about stuffing values into registers to tell it what we want back, then it's child's play, which is what I've done, because I just couldn't be bothered looking into the registers for this. I mean, it's been done so many times. I thought there's no value in me trying to dig in deep into that. Let's just, use something that somebody's used before. So all very simple then. So the wire coming in here is just VCC and ground, and A4, A5, which is these two pins here, which then go on to the top two pins here, all color coded pretty much the same, orange and yellow. Even the pins on here, you can see just about, that's got a little yellow marker, and that's got a, well, orangey marker. I think it's supposed to be red, but it wasn't really red, so I've used that as the orange. So that all works out quite well. Okay, while we're on this board, we might as well discuss a couple of other things. That MOSFET down there, that's my reverse polarity protector, because, let's face it, on this little tiny board, which is a standalone remote control, as I've said, what do you think the chances are of me whipping out this battery, because it's got flat, and putting another one in the wrong way round? Yes, exactly, quite high. So I thought, I'd rather not destroy anything when I do that. So we've got this P-channel MOSFET here that protects everything against me putting it in the wrong way round. And if you want to know more about how to implement that MOSFET, look at that video there. There we are, the one that's showing on the screen now, exactly how to do that. It's very simple and can really save a lot of heartache. There's nothing worse than connecting things up the wrong way and having the magic smoke escape. Sometimes the smoke doesn't even escape, it just sort of disappears somewhere, but your product will not work again. Yes, we've all been there. Very heartachy it is too. Now, okay, let's talk about the Wii Nunchuck again. You might not want to wire it in as I have. I've done it that way because I want this to be robust and not fall apart and all the rest of it, but they do some adapters for it. So let me go and get a Nunchuck that I haven't decimated like this, and have a look at a few other things on my desk. Okay, so if you want to use a Wii Nunchuck adapter with your Wii Nunchuck, so you don't have to cut the plug off, which means actually if you've got a Wii, you could use it for a project without damaging it and swap it around. Now there are two types of adapters. I found this one, which is a little bit more I don't know, robust I suppose you'd call it, because if you notice the cutouts in the top and bottom of there, which means when you connect this up, the little indentations on the plug, you see that I'm going to have to push those in. They then click into that, probably just to make that out, and then it won't pull out. I can't pull it across until I press in the things and it flips out. That's one way. They're quite hard to come by though, to be honest. Much more prevalent are these ones. Let's make sure we put it in the right way. So it's that funny bit at the top, because there's no center pin connection for that one. just fits in there like that, sort of push fit. You could easily pull it out again there. But for breadboard use, that's absolutely fine. Nothing wrong with that. Yeah, the inside of that plug looks like this. As you can see, there's 5 connections in total, but it's only the 2 outer edge ones, because although this middle one, middle bottom connection is black down there, you can just about make it out because the plug goes that way around. It's not actually connected up to anything that we want. In fact, it just says not connected on the wiring diagram. So there are, that's it. That's pretty easy. So if you didn't want to destroy anything, it'd be quite simple to do that, at least for prototyping use, you know. Now, if you use the library, as I said I was going to, it's simplicity itself. Here it is. That is it. Okay, but there are a couple of gotchas here, and I really want you to watch out when using this nunchuck. Using the library is fine. In fact, the library can be found here. Okay, I'll put all the links down in the video description. And they're all pretty self-explanatory. You can have a look at the library to see how it's used. But if you notice this bit here, this is commented out because they were using here to power the nunchuck your Arduino pins A1, A2. I've seen it also on A3 and A4, or A3 and A6, or something like that. But basically, that's 5 volts, and your nunchuck is a 3 volt device. You should not be connecting 5 volts to it. Even if it appears to work, it could damage it. So be very, very careful about that. And the other thing is the wiring that I just showed you in that plug. So in here, and then you have to look at the wiring. I think it's that way up. You have to hold the plug with the indentation at the top. So it's 1, 2, 3 across the top, 4, 5, 6 down the bottom. Do not go by anything on the internet, basically. Not even my stuff. Because although this is right for my nunchuck, I know that's only right because I took the plug off and checked it all out. In fact, I even took this apart to find out what was connected to what. Because let's just have a look at some of the stuff you can find on the internet. Right, so here's one page, nothing to do with what we want to do. This is talking about a micro view, whatever that is. So here, look, it says pin 2, yellow, green, black, red. Well, no, that is not the wiring diagram that I had. So that's one. Let's look at another. So this is another project that uses a nunchuck, and he says the original nunchuck, this was the wiring. Right, so green is SDA and red is 3 volts. You think red would be power, wouldn't you? No, do not believe that. And he says from the clone, yellow's SDA, green's 3 volt 3, yes. Red is ground, see what I mean? White's SCL. I think this might be the same as what I've got actually. But as I say, I didn't believe any of it because when I looked for images of the wiring diagram for a nunchuck, they were all over the shop. You just could not believe any of them. So you really will have to take the plug apart. Now, taking this plug apart on here is simplicity. Let me just take that adapter out. It's only 2 screws, and then the thing literally sort of falls apart, and you can have a look at exactly what colour is connected to what. The actual pin locations, of course, are always going to be the same. What do I mean by that? Let's have a look at this. So this is the numbering diagram. So 1, 2, 3, 4, 5, 6. You're looking from the front of the plug here, so the wires are coming out from behind. Okay, it's all very confusing. I checked mine 20 times before I connected it up, believe you me. So it's pretty easy to do, but do not believe the wiring diagram, otherwise you will blow your nunchuck up without a shadow of a doubt. Right, now as you can see, I've commented out the acceleration bit here. So if I'll uncomment this and fire it all back up again, but then expect to see lots of stuff happening over here, because it's obviously, as soon as I twitch my hand on that, it'll detect that I'm moving. Okay, here goes. Okay, now as soon as I twitch this, you can see all the stuff coming up, because inside here there's an accelerometer, which means it can detect when you move stuff left and right and forwards and backwards. Obviously it's a Wii game controller, isn't it? So, you know, like tennis or golf or something, you know, you can whack in. It understands how quickly you're doing it as well. That though is not particularly useful to me in my project, not at the moment anyway. It might be nice to control things just with a twist of the hand, but I don't know, that gets very, very sensitive and twitchy, doesn't it? I'm just going to stick with the hat. Yeah, there we are, you see. But there we are. That's I mean, there's a lot of stuff packed in here. So let's have a look how much they cost. So this is bang good. So here's a Nunchuck controller, and that is $6.75. You will, of course, incur shipping costs. So let's just have a quick look at that. Right, here we are. So shipping cost is $1.21, less than I thought actually shipping, and you can get them in black or white. But as I say, watch out for the color-coded wiring if you're going to snip that plug off. If you don't cut the plug off, then obviously it's all just going to work by putting it into one of those adapters. Did you notice, incidentally, just before we shot down this page, there's the little adapter that I was showing you. And they're only $1.53, so you could order them together. Perhaps buy a couple of these in case one gets damaged. But yeah, pretty cheap. Even Amazon sell them. Here, look, here's a couple that I bought. It was only 10 quid for two. And I thought, yeah, that'll do, because I needed this stuff a bit quicker. But for two, that's only, what, £4.50 each. That's actually cheaper than China. Okay, I think that sort of just about covers all the bases for the Nunchuck using I2C. Do have a look at the stuff. There'll be links in the video description below, but even better, do go to my GitHub, because there I can just put so much more stuff. Okay, links and sketches and just general information that is easier to get to than trying to get it from the video description below. So do have a look, and if you fancy playing about, as I say, one of these is only going to cost you $6-7, was it? Something like that. And just plug it into your A4 and A5, and you'll, thoughts will come. You go, yeah, I can use it for this, that, and the other. Okay, that's it then. You'll get a much more detailed realization of what's happened here. I'll even put it in the case, look, but all that will come in due course when I do my final project. I hope I haven't over-egged the pudding here. I'm not trying to, be coy about this big project of my big project. Just that I'm following somebody else's project, something that I wouldn't know how to do normally. So I'm just doing it step by step and making sure it all works. Okay, if you like this video, don't forget to give it a good old thumbs up so that YouTube know it's worthwhile offering to other viewers. And comments down below. It's always good to have a chat with you. And see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.